I think there's somebody online. Hopefully, the people online can also hear me well. Good, good. So, welcome all of you to join our training event today. And my name is Cooking. So I'm from Huawei Digital Power team. later, Dr. Liu will briefly introduce what is digital power. Today, we have a big team from Huawei side and also a big team from Photomate side. And thanks to Aprilice, they help us to invite you to join this event. Great, great. And briefly introduce the team members from Huawei side and also from Photomate side. So,
yeah, my name is Patrik Sartev. I've been in Huawei for 9 years. So I'm responsible for the sales and business development in the digital power here in Sweden then.
Yeah, my name is Torben Christensen. I'm responsible for Scandinavia for Photomate. We are VAP for Huawei. Means that we are the one who have the products in the stock. I have my team with me over there. If we start from the left, we have my Polish colleague, Rafał, and a new member of Photomate. We have William Peterson there, and then we have Dama. He is sitting with all our service cases. That's actually the team I have here today, so I don't know who should continue.
Sui.
Hello everyone, I'm Siwei. I'm responsible for channel partners. Me and Cooking, we're both responsible for Digital Power Nordic partners.
Thank you, Sui.
Hi, my name is Liu. I do solution manager. So I believe in the future we are going to have a lot more communications on everything about our solutions.
Thank you, thank you. And the agenda today, in the morning session, we will cover the, let's say, more serial part, the key features or functionalities of our product, inverter, battery, optimizers, and some kind of communication devices. And we will continue until, let's say, 12:30. We will start the lunch. During the morning session, we will have a one-time break, coffee break. And 1 hour lunch, then 1:30 we will continue in the afternoon. It will be more practical part. So Rafa from Photomate side, so he will lead the presentation and the introduction. I think afternoon session we might continue until 4 or 4:30, depending on the questions and interactions. So we are very flexible. So this is the brief agenda for today. And during the morning session or during the afternoon session, feel free to ask your questions. I believe that no matter what level of questions, everybody in this room will benefit from that. So feel free to ask. What else? I think otherwise we can start. Yeah. Thank you. Hopefully you will enjoy today's session and you will learn something from us. Thank you. Okay, let's start.
Okay.
And we have 2 microphones. So if you have any question, you can use a microphone. So they are open for use. One is this one, the other one is over there. So I put one microphone here. You can share. Yeah.
Okay. Good morning. The morning session is mostly about features and highlights for a smart PV solution. Because we believe that for installer partners, there are 2 major support that we can provide. First one is about how to sell these solutions, and afterwards is of course it's about how to use these solutions to its benefit. And let's begin with a short introduction about Huawei Digital Power. Digital Power is a business group inside Huawei. Huawei is a big company and there are big business groups. And actually right now, for the moment, within Huawei, there are 5 business groups. And Digital Power is one of them. And within Digital Power, we have 5 business units. And Smart PV is, of course, the focus of today. But side by side with Smart PV, there are also side power business unit. That's the business unit providing side power solutions for telecom site, fixed network site or mobile network site. Let's say if you have run into customer want to do this kind of site renovation or site upgrade, then we can always provide the site power solutions. And another business unit is dedicated to the data center facilities. We know that cloud is becoming a more and more important part of everyday life. So more data center going to be built up. And this data center facility business unit would provide modular building blocks for building a data center from scratch. And this is about data center facility business unit. And we have smart PV. And another two is M-Power and modular power. And these two business unit is mostly providing solution for industry or domain partners that to be integrated into their solutions. Like in this part, we provide the charging modules, converting from AC to DC. And those charging modules can be piled up to create a solution for charging station. And this part is providing the data modules. No matter how big size, we have different sizes of power modules that's supposed to be integrated with different products. That's a general overview about digital power and the department, our business unit solutions that we can provide from the digital power business group. And next one is about something about inverter itself. You know, right now we are very focused on the development of inverter based on the string architecture. You know, for solar system, we always chain the solar modules together as strings. And this string inverter means that we are trying to give every string a dedicated input on the inverter itself. I mean, another solution would be simply combine different strings together and give only one input to the inverter, and that's so-called centralized solution. But for Huawei, beginning 2015-2016, we are dedicated to the development of string inverter and string inverter only. And over the year, we see that string inverter becoming a dominant technology adopted by different partners on this PV industry. So that's the right way to moving forward from our point of view. And all of our inverter we released to the market is based on the string architecture. And the next thing is about the killing performance. And this is data from the middle of last year. Huawei all over the world accumulated delivered over 175 gigawatt inverters to all the customers around the world. And that's also ranking #1 among the suppliers of inverter in this business. And right now, that number has go above 220 already. Any question? No? Okay.
How big is the entire market?
Sorry?
How big is the entire market?
Entire market?
Yeah, you have now 220. How big is the total market?
Well,
So what's your market share in that sense?
in that sense, around 1/3.
Okay.
Around 1/3. Yeah. And that's also largest share compared to any supplier in this PV inverter segment. And something about smart PV. So today's focus will be, of course, on the residential solution and the commercial and industry solution. But one thing to mention is that in addition to the residential and the commercial industry solution, we also provide ground-based scale solutions for those big PV installations. On this side, we have inverter of higher volume and also transformer station and energy storage solutions. And for the residential and commercial side, we have inverter 1-phase, 3-phase, with capacity ranging from 2 kilowatt, 3 kilowatt, up to 100 kilowatt. And the difference is that on this side, residential and commercial and industry, the AC side is always 400 voltage. So for the three-phase connection, 400, and for the one-phase, of course, is 230. But for this side, the AC side is always 800 voltage. That's the difference. And also for the residential solution part, we provide also the energy storage solutions like that one on that board. It can be a good solution for the energy storage, for the arbitrage or make optimization to the electricity cost in the home. Okay, that's a general overview about the solutions that we can provide. And it's also the established way of looking at PV applications. It's always based on these three scenarios. Now let's have a look about the smart PV solution itself. This is an overview of residential smart PV solution. FusionSolar is a brand, and you can see that in the middle of this solution is the inverter. This inverter itself. And for the residential solution, we are thinking about inverter with capacity ranging from 2 kilowatt to 6 kilowatt for the one-phase inverter, and the three-phase inverter ranging from capacity from 3 kilowatt to 10 kilowatt. So L1 and M1 inverters. And all this inverter has the possibility of connecting to a energy storage. Possibility means they are a battery interface on the inverter. It's dedicated connection to the energy storage. And in addition to the energy storage and the inverter itself, the next biggest component, important component that we can provide is actually the optimizer. Optimizer is a small component like this, and it's supposed to be connected to every solar module. And optimizer suggests the primary function is optimizing the energy output from a solar module. So if a solar module got shaded or blocked, partially blocked, this optimizer has the possibility to adjust the voltage output to make sure that they are good. The affected solar module has the same, more or less the same current as the other modules in the same string, so not affecting the whole string's performance. And another benefit brought about by the solar module is actually shutting down the output of solar modules, because sometimes, especially during some accidental or maintenance time, you would like to have a low voltage output from the solar modules, and that can be achieved by using these optimizers, because this optimizer has a small chipset built in, and this optimizer will keep on talking to the inverter. So if inverter does not answer, or inverter told it to stop output power, then the optimizer will simply give a very low voltage output. In the end, it will become 0 voltage output at all, to 0 voltage output. That's so-called rapid shutdown. So for the performance is that we can achieve very low voltage, safe voltage within a short time. We can talk this later. And another benefit of this optimizer is actually the modular level monitoring. So for a residential customer, let's say if they have 30 pieces of solar module installed on the rooftop, and it would be nice for the customer or for the installer partners to understand if every solar module is working properly, working in the right condition. And this optimizer gives you the possibility to do this kind of monitoring, because in the application, FusionSolar application, you can find out what's the output of each solar module, or what's the output from each optimizer. And that's so-called module level monitoring. And the last benefit brought about by this optimizer is actually the flexible design of the string length. Sometimes on the rooftop, you have a very complicated situation, and the inverter suitable for that size may not have necessary amount of input, I mean string input. So let's say for this one, this is 10 kilowatt. They have only 2 inputs. But if you choose to give every, situation or every string a dedicated input to the inverter, sometimes it's not very possible. And the solution would be giving a optimizer to every solar module. And in that case, you can have a string longer, in terms of the voltage, long enough to make sure that you use only 2 inputs and connecting all the solar modules on the rooftop. Well, Huawei want to provide an end-to-end solution that is covering everything other than the solar modules mounting systems. So in addition to the inverter energy storage optimizers, we provide also the smart power sensors. And this part is a very critical part if you have energy storage installed in the system, because for the energy storage, we also always need the help from a meter to understand the solution-wise, understand when the discharging could happen. This meter is a bi-directional meter, so they can tell not only how much energy is flowing from grid into the home, but also can tell how much energy is flowing from home to the grid. For the communication site level monitoring, we provide these dongle solutions. There are 2 options. One is based on Wi-Fi and Ethernet communication. Another one is based on the 4G communication, telecom 4G communication. And on the cloud side, we provide a smart PV management service. It's a management system, and the system can be accessed with applications on the cell phone or with a simple browser. You can access this management system. And the data collected from the inverter will be stored here on the cloud in this management system to facilitate the daily monitoring or some application. And another thing I want to mention that we also provide API from the cloud. So if you run into any third party would like to do some development to provide a special function to your user, it's possible to integrate it with the API from here and providing function from the cloud side. Okay, what question?
Yeah, I have a question there. So if you want to capture that signal directly from the smart energy center, can you do that via M-Bus or something like that?
Yeah, Modbus.
Yeah, you can do that directly from the smart meter. Or do you, from the energy center. Oops, sorry. Can you capture that signal if you have developed your own system to monitor? Or do you have to do API?
This dongle.
Yeah, but if you don't want that one, I have a very special customer who thinks he's smarter than Huawei. So he's built his own system to monitor his entire house. And he's one guy. He wants to be off grid, and he wants to capture the signals from the energy center. Is that possible?
Yes, that's possible. The option look like this. They are smart dongle. One of the dongle is a dongle with Wi-Fi and Ethernet communication, right? And this one also support Modbus communication.
Okay, cool.
So if the people choose to do the yeah, or no?
Well, yeah, I have a question. With the API, does that mean theoretically that if you have a battery, that you could make your own with the API a connection to the Nord Pole spot market?
Yes, that's a very good application actually, connecting to the Nord Pool and get the forecast of spot price and changing the time frame when to charge, when to use.
Do you know if anyone has done this?
Yes, there are partners on the market doing this. I mean, quite some partners is asking about this API. But I'm not sure if anyone has the commercially available things released yet. So for the Modbus communication, it's possible. So basically, if you have a Wi-Fi Ethernet dongle connected, then you can use a small computer, talk to this dongle over Modbus, and by writing those registers, then you can get the information from this inverter or give command to this inverter.
Cool. I have another stupid question.
Yeah.
And so if I haven't had one optimizer fail yet, but if one of the panels fail and you have optimized, will that send a signal so you get an alarm, or do you have to monitor it manually? Is it automated like that?
You mean fail?
Say if one of the solar panels fail, you can see that on the app. Obvious, you can see it. But
Yeah,
will it tell you that is it like proactive?
You mean some kind of alarm?
Yeah.
I'm not sure. Do you know that one?
I haven't seen one fail yet, so I don't know.
It will not trigger the alarm. You are able to see the monitoring level.
Yeah, so you have to go in and actually look at it.
Yeah.
It will be just offline, or you will see like the parameters of the PV module
Yeah.
decreased significantly comparing to the others.
Okay. Could that be a request for a function? So had people ask for it. I don't want to go in and check every day, they said, but if something fails, I want to know.
Yeah, I mean, but the list of the alarms is not endless.
Okay, yeah. But if it fails, right, so...
Yeah, I mean, there are some type of alarms, but most of them regarding the optimizers is about the fail of the optimizer itself.
Okay. Okay. Okay, thanks.
Okay, any question here? No? Oh, okay, let's move to the introduction about commercial and industry solution. A commercial and industry solution implies a bigger rooftop. I mean, like in a school or in an apartment building, the roof size is bigger. And for this scenario, we provide also inverters with bigger capacity, like from 12 to 20 or from 30 to 40 M2, M3 series inverter. And the key thing is that for these two series of inverter, optimizer is also available. So even for very big rooftop, you still have the possibility of using optimizers. And another thing is that we also observed that, found that on the market there are more solar modules with higher current higher capacity. And so soon we will release this 600 volt optimizer to the market. So for Huawei, the optimizer is very simple. It's always up to the capacity, the power. So for 450, that means any solar module that has a smaller capacity, smaller than 450, this optimizer is a valid choice. And later we are going to release 600 volt optimizers. And even later we will release another optimizer that's 1300 volts. So one optimizer for two solar modules. You know the truth. And for this commercial and industry installation, with a capacity comparable to a few hundred kilowatt, we also provide a dongle solution as a communication choice with the cloud. And the dongle is the very same dongle used in the residential solution scenario. It's a Wi-Fi Ethernet 1 or 4G communication capable dongle. And the specification is that one dongle can manage up to 10 inverters cascaded together. So it's possible to cascade multiple, let's say, M3 together and manage all those devices with one dongle. And for this commercial and industry solution, we also provide this management system on the cloud. And it's very same management system as the one just described in the residential scenario. And also this management system can be accessed through the application on cell phone FusionSolar application or from the web browser by visiting a special address. It's internationalfusionsolar.huawei.com. And also for this installation, we can provide a smart meter solution. This smart meter is 250 amps. I mean, in terms of the amps running through this wire. So if you do the math, you find this is 120 kilowatt capable meter. So for installations no larger than 170 kilowatt, you can use our smart meter. And this one is already readily integrated with our system. Reading and managing should be always possible. Any question here on this smaller scale CNI? Yes, another application is actually providing solution products for commercial industry with even bigger rooftop, such as warehouse, such as a big shopping center, and where you would need comparable around megawatt installation. And in that case, we provide 100 kilowatt inverters. And 100 kilowatt inverter need a dongle that can do only 4G communication. So the Wi-Fi Ethernet dongle is no longer possible in this setup. And another choice is actually using a smart logger. The performance of specification of dongle is 10 devices cascaded together. But for the smart logger, you can have much more inverters cascaded together. The specification is 120 actually. And also smart logger has more interfaces and more built-in functions for accessing devices, peripheral devices, such as a irradiance meter or a weather station to detect the temperature or solar irradiance and collect those information to the management system. And also there are a list of supported power meters and other weather stations. And if you choose a device from the list, then this one can read those things from already and reply those information to the management system. And this is also the very management system we talked in the residential and the smaller CNI scenario. It's very same management system, same management system on the cloud. And it can also be accessed via the application on cell phone or web browser. Another thing is that this very same management system is also ground-based installations. That's a very big installations, has an inverter with bigger capacity and 800 voltage output on the AC side. It's also possible to do those kind of management. So this is a thing we have on the cloud. Optionally, we can always also deliver this into the site. Let's say if you have a customer want site local management, we can also provide this solution to the site local installations. Okay, any question here? No? Okay, let's have a look of different features of Huawei Smart PV solution. The first one is about electricity generation. Always we want to have more electricity in use, getting more from the solar installation. And for this consideration, we have solution like a Sun 2000. That's for getting more energy from the sun during the daytime. And another side is actually about Luna 2000. That's about making use of electricity when the sun was not there during the evening time. So covers 24 hours. We can always provide solutions for the optimal energy usage. The first one component that would optimize the usage of output of solar module is optimizers themselves. We can see that from time to time there can be shadows on the rooftop, or there can be a tree standing side by side with a roof, so there can be blocking of the sun shining on the roof. And in this situation, if there's no optimizer, the affected solar module would give a lower current output, and every solar module on the same string with this one will have a lower current, and the power output will be reduced accordingly. And that's something we really want to avoid. And the optimizer can help in this situation in that they will adjust the output of this affected solar module, specifically adjust the voltage output and accordingly rise up the current. So the current output of this solar module in the optimal situation could be adjusted to the very same level as not affected, as the level of those solar modules not affected by the shadow. And that's the very theory why this optimizer could optimize the power output of the string. Yes?
Well, if now you can put one optimizer on only the shaded panel, right?
Yes.
What would that be in terms of the effect on the other panels if you only had one optimizer in this case on the shaded area? How would that affect the others or in total?
Well, if you have, well, that's a very typical way of using optimizer. Let's say on the rooftop, you are quite clear that some solar modules will be affected from time to time, have a current output lower than other solar modules. So you can put up only optimizers to those solar modules. And this solar optimizer will work as it's supposed to be. I mean, when the current output is lower, this one will start working and reducing the voltage output, but give higher current output. So not affecting other solar modules. If optimizer only installed on this panel, the optimizer will only affect the output of this panel.
So the other panels would be 100% still?
In the optimal situation, yes, but it depends how this one got affected. If it's a very dark shadow, then this one will also optimize, but I mean, before this one got totally blacked out by the diode inside, the current will be drawn down as well. So how much they can improve is actually up to the situation on this panel, how big a shadow they have, how dark a shadow there is. That's optimizer for optimizing the output of solar module. Yeah. Any question? No.
Does it have like a minimum amount of optimizing each string, or do you need to have you can have like one optimizer, or you have a minimum amount of?
No, you can have as many as you want. And another thing is about the comparison of using optimizer and not using optimizer. We can see that with optimizer, you can always get better energy output. Even the solar module is installed on the same direction and same irradiance condition. Even with this kind of installation, you will get some benefit from in terms of energy output from the optimizers. And this is something that we want to mention because sometimes 10% or to 13% more energy output really make sense to the use of to the purpose of this PV installation.
Can you explain why?
Because even if you do not notice, there can be differences from time to time. Let's a cloud running through for a while, and without the optimizer, you get some kind of block here. I mean the block. I mean the output of the solar module will be affected, and the solar module on the same string will get affected. But with the optimizer, I mean those kind of shadow can always be avoided. So optimizer is a good thinking, represent a good way of thinking the solar installation. And this is about the long string design. Well, you can see that on the rooftop, sometimes you have a rather complicated situation, different orientations and different angles and different sizes on each piece of the rooftop. But preferably for this kind of installation, but we cannot have three, would be give, let's say, 3 inputs to the inverter, because then inverter could address maybe solar modules on the same orientation or same angle. But in the case of M1, you have only 2 inputs. Then you can consider this long string design. In that, give optimizers to every solar module and chain those solar modules from different direction into one string and got that long string connected to the inverter. You know, when you are doing the calculation of string length, you have to consider the voltage, the accumulated voltage on each string. And without optimizer, if you want to follow that voltage limit, then maybe you can have, let's say, 18 or 19 solar modules in one string. But with the optimizer fully installed on every solar panels, you can have maybe a string length longer than 25 for some time. So that's so-called long string design. And the limit of long string design is that per string input is, for M1 series, is less than 10,000 watts. So this is a kind of design flexibility brought about by the optimizers. Okay. Yes, for the evening time, we provide a energy storage solution to make use energy maybe generated by the PV system or even charged from the grid. And for us, this battery system is divided into smaller modules. You can see that this is a 5 kilowatt hour battery pack. And in addition to the solar battery cells, we have optimizers in each battery pack. And this optimizer will do the monitoring of the performance of each battery pack and also can bypass one battery pack altogether. This optimizer is quite critical for the usage that if you have old and new battery pack mixed in one stack. Because this optimizer can control the voltage on the cell side and also on the bus side. All the battery packs are connected in parallel to this control module. And connection in parallel has the implication that the voltage is always the same on the bus side. But this optimizer gives the possibility of adjusting the voltage on the cell side and on the bus side. And that's the foundation why you can mix old and new batteries in one battery pack. And this capability of mixing old and new battery in one battery pack gives the possibility of expanding installation of energy storage with a step of 5 kilowatt hour each expansion. We can see that. So at the beginning, you can have only one battery pack in the system with a controller, of course. And over the time, the system can be expanded to up to 30 kilowatt hour connected to one inverter and without any performance degradation. I mean, let's say first year you have 5 kilowatt hour, but next year you have another 5 kilowatt hour integrated into the system. And although the battery installed in the first year get some certain kind of degradation already, but the new battery installed in the second year will working properly with the battery pack installed at the first year. So that's a very modular design and supposed to help you to increase the amount, to help the customer to build up a big system step by step instead of provision a 10 kilowatt, maybe a kilowatt hour system at the very beginning. And also this battery pack is 5 kilowatt hour is relatively small. It's 50 kilograms in weight. So one person could handle this batteries. It's possible for one person to handle it, to lift it up, put in the position. And well, we can do 100% depth of discharge because the capacity is actually a little bit big than 5 kilowatt hour. So for 5 kilowatt hour, you can enjoy 100% 5 kilowatt hour, no problem. And yes, and with the next one is about a design about the inverter. We can do the charging and inverting. I mean, providing AC power at the same time from the inverter. So the inverter can charging the battery and in parallel also give power to the workload. And another thing I want to mention is that in a bigger system, you can have 3 inverters cascaded together, 3 M1 cascaded together, and each M1 could have up to 30 kilowatt hours battery connected. So for the bigger installation, you could have up to 90 kilowatt hours energy storage for home or for a small business office. And it's also possible to incorporate Huawei energy storage solution to a existing PV installation. I mean, not necessarily always using Huawei energy storage with Huawei solution. It's always possible to incorporate Huawei energy storage solution to the PV system from other suppliers. Okay, any question from the energy output side? No? Okay, now let's...
Yes,
yeah.
So is there any development going on? Because now the control unit can support 3 batteries, right?
Yeah.
Is there any development going forward, just for the customer's information, to add more batteries to one control unit? Or is that the maximum? And will
3 is the maximum.
And there's no development to support more in the future?
No, not yet.
Not yet?
No.
Okay.
So if you want to do the expansion beyond 3, so you can start another stack. Next consideration is about safety. In the home and CNI scenario, we always have the rooftop installation, mostly rooftop installation. And we would have the solar installation quite close to the people working or living in the house. And in this case, safety is quite critical because you would have quite many connectors, and if the connectors are not properly handled, there can be arcs between the small gaps inside a connector. And once the arc happens, DC arc happens, it will not stop because the direct current is just running as a direct current, not like AC, they're changing from time to time. And once the arc happens, we can see that the temperature will be above 3000 Celsius. And that's a temperature nothing in the ordinary life, everyday life can hold. So once arc happens, it will simply burn down until burn out, until the thing that triggers the arc burns out. So arc is a very big issue for the PV system anywhere because, well, from time to time you can heard about this bad news, some installation burned out. And to address this arc issue, the first consideration would be how to detect arc. And arc doesn't mean that string get totally cut off. It's still connected in terms of the current running in that loop. So how to detecting arc is a very critical issue because arc itself presents itself as a small different signal, a signal differences in the voltage and current output, and there could be very strong noisy on the wire from the point of view of inverter. So how to detect arc is very challenging because there are different interruptions for the inverter to correctly detecting this arc. And from Huawei perspective, we have developed a artificial intelligence-based arc detection algorithm. And this algorithm is trained from by signals collected from different situations. So the result can be very, very accurate. 100% accurate. As soon as this one told you they are arc, they are arc. And with the help of this accurate arc detection, the inverter has the possibility to react to arc in a very short time. I mean, the performance for us is arc detection and arc shutdown will happen within 500 milliseconds. And that's the performance we could have. 500 millisecond arc will be detected and shut down, and it's way above the requirement from standard. This is a demonstration about arc. So once DC arc happens, the arc will continue. And with AFCI enabled, the arc happens and arc got shut down almost within a blink. And no disaster will be triggered. But if arc continues like that, simply will burn down everything nearby because of the high temperature. So AFCI is a feature enabled on all the inverter by default. And another improvement for the CNI situation is that we can do arc detection over rather long cables. And this would be critical for the installation on the big rooftop, right? Because for the big rooftop, you would have cables running maybe no more in terms of a 20 meters, 30 meters. It can be over 100 meters. And our performance is that we can do this arc detection up to 200 meters. Any question here? Yeah, and this would be the feature or another benefit brought about by the optimizer, shutting down the voltage output. Like just explained, this one has a small chipset built in that try to communicate with the inverter to understand if this optimizer should continue with its work. That's output the voltage from the solar module. But if such communication got interrupted, let's say you turn the DC switch on the inverter, or press a signal, give a signal to the inverter will tell this one, you shut down the output, or this one lost the communication with the inverter, it will also shut down the output. And that's critical for people who need to work on the rooftop in the not so easy time. And the performance for us is that within 30 seconds, we can reduce the voltage output of a string below 30 voltage. And if the string length is less than 30 solar modules. And that's so-called rapid shutdown of the voltage. And that's critical during the fire times. People need to go to rooftop and would like not get electrified by the solar modules. That's the benefit brought about, safety benefit brought about by the optimizer. So consider this one. It can be very critical during difficult time. And another benefit of optimizer is actually to do the module level monitoring. Since we can do module level monitoring, so with the optimizer installed on the solar module, it's possible to understand where the arc really happens. Because without solar module, once the inverter detects the arc, this one will give alarm for sure, and also shut down that string's input. But if people want to do the maintenance, go on site, then you have to check one by one which piece of solar module on that string has the arc detected. And that can be time consuming, and if you have optimizer installed, the optimizer could tell you which solar module has the arc happened. And then when you go on site, you would have a more clear target where to look at. This is actually another thing attached to the optimizer is that with the help of optimizer, it's possible to input the layout of solar modules into these management systems because there are stickers on each optimizer, and you can use the sticker to input the layout into the system. We can talk about this later. And another safety consideration is actually for the energy storage. That's battery, lithium battery, very big lithium battery, and lithium battery sometimes can run risky. And from the safety consideration side, for the lithium battery, we have 3 levels safety consideration. From the choice of the battery itself, we have chosen the most safest choices of lithium battery, that's so-called LFP cells. And that kind of lithium battery would not run off even for a very high temperature. The performance should be 480 Celsius degree. Below that, the battery cell will keep it stable, not run off. Even if you have compaction pierced through the battery cells, they just release some gas and will not burn. During the operation. And another system-wise design is the optimizer itself. Optimizer will, together with this controller unit, will keep a close look on the solar module all the time and keep looking the output of the voltage output and current output. If the failure detected, a controller unit will give a command to the optimizer, and optimizer will shut down that battery pack immediately. So before there's any issue progressed, developed into a real risk. That's so-called system level safety. And also in each battery pack, we have sensors built in to help the controller unit to understand what's the situation in each battery pack. And from the pack level, we have sensors. From system level, there are optimizers in the battery pack that can shut down the battery pack immediately if the control unit found something wrong in that pack. So this one would be a safe solution even if you install it indoor. Actually, this is a lithium battery. It's quite suggested you install it indoor, in the house or in the apartment. Not mostly for the temperature consideration in the northern part of Europe. Well, for our inverter, it's a so-called grid-tie inverter. That means this inverter needs the AC waves from grid to understand how to export the energy. And if there are shortcut or if there are outage on the grid side, that is, there are no more AC on the AC connection, the inverter is supposed to shut down itself. Give no more output, AC output to the grid, to this so-called anti-islanding, or avoid this one become an island in the big grid electricity power network. And that's a safety consideration. But from other perspective, since you would have a solar installation in the home and with a battery at home, you can enjoy electricity all day long. So even if there are outage on the grid side, you would like a solution that can give also using the power from this installation. And the backup box is the solution to enable this electricity usage during the outage of power grid. And the theory is that this backup box could detect if there are outage on the grid side. If there are outage detected by the backup box will shut down itself, shut down the connection to the grid, and also give a signal to the inverter, told the inverter that although there are issues on the grid side, but you can continue with your work. Then the inverter will continue its work using the energy from the solar module or the energy from the battery to feed those power to the workload connected to this backup box. And that's the very purpose of this backup box, to provide energy during the outage of the grid. It can make sense for the installation, standalone installations. And for the backup box, we provide two alternatives: one-phase backup box and three-phase backup boxes. So up to the situation, up to the connection to the grid. Any question here? No. Now let's talk about the experience. Huawei solution is a very simple solution. It's a one-fits-all solution or one-stop solution. Well, from the optimizer side, we have we have only one optimizer at the moment, and the selection optimizer, you consider only the only factor you need to consider is actually the capacity of the solar module. If it's less than 450, then you can always using this optimizer, almost always using the optimizer. But sometimes you have to consider the voltage input. This one has 80 as the maximum. So that's one optimizer could fit almost all of your need for a selection of the solar module. And later we have 600 volt to fit to those bigger solar modules. And also we have only one battery choices, and the battery can be used with a one-phase inverter or three-phase inverter. No differences between the battery systems. And also for the connection to the grid, during the time grid are working properly and during the time that grid has outage, we can always using one inverter plus a backup box to adapt to the condition from the grid side. That's so-called one inverter. And since we can deliver all those things, energy storage, inverter, optimizer, power meters, all those things are in our offering to the market. And all of things can be managed with one application. It's an application on the cell phone or directly connecting to accessing the management system on the cloud. So that's one application managing everything. Well, for service window, we know that if you do the PV installation, it's usually two-step. You do the DC side installation first, and then some electrician go to the site again and do the service provisioning on the AC side. And for the AC side installation, it can be using only one service window because we have Huawei energy storage, Huawei inverter, and Huawei optimizer, and Huawei power meters. You do not have different things from different factory and using different service window. We do not need that. One service window, you can have everything provisioned. That's so-called one fits all. Another thing that we consideration is provisioning. During the provisioning of equipment, you have everything connected, then you can try to see if everything can show up in the FusionSolar application. And this is hardware provisioning done by the FusionSolar application itself. And the FusionSolar application itself will try to detect if everything is there and detect those things automatically. So when you have the FusionSolar application started and go to the site provisioning or provisioning choices, then the application will try to detect if there are power meters in the system, if there are energy storage in the system, how many optimizers was there, and all those things will be managed by all those detection will be done by the FusionSolar application. And you do not need to do manually add a ESS, manually add optimizer. And this would be a saving of time and also is easy your work on the site. That's so-called auto detection. And this one is about how to mapping the layout of the there should be a video here, but I'm not sure how it doesn't show up. Well, actually, this one is about how to map the layout of the solar modules into the system. The idea is that you give a optimizer to each solar module, and for each optimizer, there's a small sticker on the solar module, on the optimizer, and you can take out that sticker and put it on a special paper, like follow the layout on the rooftop. And afterwards, you can scan the layout by the cell phone and get the layout input into the system. And after that, you would have a module level monitoring of the PV system, and also you could understand which module on which position is giving what performance. Especially during the failure time, this layout could help you to understand the target more directly, understand where is the target. That's so-called auto mapping, module auto mapping, and the condition is that you're using an optimizer on each solar module. For the communication, we have two choices. For the small installation, that's Wi-Fi dongles. Dongle can be based on Wi-Fi communication or cable Ethernet communication, or based on the 4G communication. Of course, this one is mostly used, and for each inverter, we would have this one included for M1 series. Okay. It's rather easy. You just stick it on and provision the Wi-Fi connection or Ethernet connection. Then you have the system connected to the cloud directly. And this is the performance of a dongle. So a dongle could manage inverters cascaded together. Up to 10 inverters cascaded together can be managed by one dongle. And that can be a saving on the installation, because compared to the smart logger, the next choice of communication, this one is much cost efficient. And for the quality perspective, we want our product can be used in the outdoor. I mean, exposed to the nature, to the force of nature. And so from this perspective, we have different considerations. Number one, we do not use fuses, I mean, among the string connections. We know that some connections need fuses to protect the string from the damage or from the current from other strings. But in Huawei installation, we have less string in each MPPT, so we do not need fuses. And also, there's only light blinking on the panel. There's no weak LCD built on the panel, so no need to do that kind of repairment. And this one can adapt itself to more tougher outdoor environment. And there's no button. You do not need to push different buttons to make it work. There's only a DC switch that is movable on the inverter. And from the thermal design perspective, we have a very efficient cooling design borrowed from the design of a base station. And this part is actually done in the R&D center in Stockholm. And you can see that it's a non-symmetrical design of the cooling fans. And so we can avoid the fan box in the system. So up to 10 kilowatts inverters, we have no fan boxes in the inverter. And that's not only brought about very quiet experience, but also critical for the operation, because if there is a fan box, the fan box can be broken quite easily compared to passive cooling design. And with these considerations and these designs, we can achieve a failure rate less than 0.5%. And that means, translated another way, that even if you do 1,000 installation, then you are not expecting more than five failures during 1 year time. Since the inverter itself is quite small, can be held up by one person, replaced by one person, so the system availability time can be up to 99.99%. And those numbers are backed up with a technical report we got from the third party. So this is a very tough design, and it will simply working over there, not creating trouble for you. Yeah, and here is a introduction about the FusionSolar application. I guess most people had some experience of it already. And in the FusionSolar application, especially for the account for the end user, it's rather easy to use and expand itself by the application itself. From the application, you can see how the energy is flowing. It's flowing from grid to battery, or flowing from PV modules to the workload. That so-called workload, energy flow, can be shown in the application, give you a general idea what is going on inside this PV installation. And with the help of that PV layout auto mapping, you can have a understanding of the performance from the layout perspective. Let's say, which solar module on which position have what kind of performance can be found out from this physical layout diagram. And another information we provide from this FusionSolar application is the statistic numbers. Tell you how much energy you have output, how much CO2 you have saved, or how much money you have saved from using the electricity from grid. Any question over here?
regarding the money saved, can you add or change the cost?
Yeah, you can. You can change the unit cost, but yeah, this is only it's a way of help you to understand the saving. But of course, the electricity price is changing quite a lot recently. So this is just a general idea, more adapted to situation.
You cannot change the price.
You can change the price, but you cannot change it. I mean, it's not very practical to change it to reflect this kind of change on the market. So in summary, and let's repeat the features and the benefit of this smart PV solution. So we can achieve up to 30% more energy with the use of optimizers. And the optimizer could be a big help for you to get more energy from the PV installation. And another one is that the energy storage system has optimizers, and the optimizers brought about the possibility of expanding a ESS from very small installation to rather big installation. And also the inverter can do the charging and the power supply at the same time and with the same power need as the energy, as the battery, and also the need of the workload. And we have AFCI, that's AI-powered AFCI, very accurate detection of arc, even if arc really happens, and very prompt action on the arc, shutting down the connection to that stream, the stream where arc happens. And this optimizer gives you the possibility of shutting down the voltage output in the very short time. And that's critical for people need to working on the rooftop, especially during difficult time. And with the help of optimizer, you could understand the situation of each solar module. And during the arc design, if arc really detected, this optimizer gives you the possibility to understand which specific solar module has the arc. Is the place where the arc happens. If you want to do the maintenance, go there to change the connector or changing the solar module. This pinpointing the arc fault position is a big help. You do not need to run through every modules on that string. And one-fits-all solution means that Huawei Smart PV has provided almost everything, from optimizers to batteries to inverters and to the power meters, and everything you need in other than the solar module and the mounting system can be found in our product portfolio. And for the understanding of physical layout of solar modules, you can using this auto mapping function, and this function would help you to understand how the modules are actually layouted on the rooftop, and that's a big help if you need to do the maintenance afterwards. And also, all those things are based on the natural cooling. There's no fan box, there's no noisy from fan box, and you don't have to do the maintenance or replacement because moving part always fails more easily compared to this passive cooling design. That's the strong point from this smart PV solution. This one I think is really cool because up to 60 kilowatt inverters, there's no fan box, there's no noise of fan box, there's no failure of fan boxes. Yeah, this is a list of different components for the residential solution. One-phase, three-phase choices, and this is a list of features and specifications of C&I from 12 kilowatt up to 100 kilowatt capacity. Well, that's pretty much everything. Do you see any question here? Or we can have a small break and then come back with questions. How about let's have a break and then come back like 11:30. Thank you.
Thank you.
get back. Okay. How about now? So 10 minutes after 11:30. Any question? Let's go to the question and answers section of this morning. And have you seen any difficulties or issues during your installation process? I mean, we have a more or less complete PV system set up here. There's one inverter, one energy storage, and one backup box. Also, backup box may not be that popular yet, but inverter, you can see that this is an inverter, and generally speaking, all this small inverter should have a dongle connected, get it connected to the cloud. And you can see that also the connection is very simple. And if you pull out, you can simply click it up and fasten it with this lever. Both the signal connection and the power connection can happen this way. You do not need any screw to fasten it or release it. Yeah, and this is a quite tough build. And it's supposed to be installed outdoor and withhold any rough environmental forces. Yes, any question would be helpful about you when you are trying to suggest this system to your customer or using this system afterwards. Have you run into any issue? Welcome.
What's the market share you have in Sweden?
Well, we think it's around 30%.
30%.
Yeah, at
the
least.
Biggest competitor?
Sorry?
The biggest competitor, is that SolarEdge?
Yeah, SolarEdge, something like that. SolarEdge, for the news. Yeah.
Okay.
Yeah.
I have a question. Maybe you can't answer it, but maybe someone else can answer it, because we're getting more and more battery requests, and we've sold quite a lot of batteries lately. When it comes to the backup, I know that the Swedish Vattenfall and Nacka Energy and all these seem not to know how to ground this, if it needs an extra grounding. Do you know, or does anyone know here regarding the grounding of the battery for backup?
They need to be grounded. I mean, what do you mean?
It is grounded in the house.
Yeah.
But like Nacka Energy is saying that you need an extra grounding rod into the ground.
You mean a dedicated grounding pole?
Exactly, for the battery.
Just for the battery? No, I do not know that. Why was that suggested at all?
Because
I don't think it has anything to do with the battery.
Backup.
It's because of the backup system.
It's because of the backup system.
The inverter doesn't provide any neutral point. You have to create a new neutral point in the ground, because we have the TN system in Sweden, because our ground specifics in the soil. Other countries have TT systems. They have a neutral point in all houses, but not in Sweden.
So there is need to put an extra grounding.
But in that case,
but only with the 3-phase, not with this 1-phase.
This is 3-phase, yeah.
But the other side,
the off-grid system.
Off-grid system,
Yeah.
1-phase is okay.
Okay.
Yeah.
Okay, because Vattenfall and these people don't seem to know either when you call them.
No.
That's a problem.
They want it, but they don't know why.
And the thing is that I myself have batteries, and I clicked in backup with Vattenfall, and they didn't get back to me regarding anything. And then we did another customer for Nacka Energy, and they send us a 5-page long thing, and we asked, okay, we're trying to read this, what do we need? And no one knows. And we had the Nacka Energy guy come and check our installation where we actually had the backup in, and he said, well, everything looks fine.
Until something breaks.
Yeah, exactly.
Well, so it's established.
Still needed to be researched. And
for standalone house, maybe you need backup grounding. not just for these things, but everything. Yep.
Can we get the presentation on a PDF afterwards?
Yeah, of course. We will distribute afterwards, maybe through Aprilice.
And the recording as well, I believe.
Okay.
Yeah.
Okay. Anything? It will be nice to understand how the experience of using this product. I mean, do you have any way of choosing the different solutions during your offering to the customer? No.
No, I think they are hesitant
Mm?
because they look at cost.
Okay.
Optimized or non-optimized. What will it do for me in the shadow? Yeah, that's not a problem because so they don't get the full picture. So they think with their wallet sometimes. That's why optimization can sometimes be difficult.
It's a cost.
Yeah.
Yeah.
They cannot really understand the benefits of all the angles to what the optimizer is actually doing. But with this presentation, it's easier to have that discussion with them.
Yeah, especially for the safety consideration. Yeah. Because solar modules are kind of passive things. If there's sun shining on the module, then you have electricity output, and several modules connected together, then you have a voltage not safe for people.
Yep.
Even that thing is disconnected. they have the voltage higher than people can handle. So this optimizer can be.
Videos on YouTube showing the app with optimized and non-optimized, so you can just see the difference in the app. Because when you show them that, it's easier. But if you don't meet them, it's harder. Whether if you can send them a link saying this is the difference between optimized and non-optimized from all angles.
A good idea. Create some videos to have customer to check by themselves.
Yeah, just what you just showed, but from the app perspective.
One question.
Yeah.
In Sweden, I think we talk quite a lot about EMC issue.
Yeah.
So especially when we have the optimizer on the roof. So from Huawei side, so what's your opinion, or what's your solution regarding EMC
we are very
issue?
careful about this EMC for sure. And also we always try to address this EMC issue, and everything we provided here to not only Sweden, but also to Europe, will pass those follow those EMC directive that as a kind of directive in Europe. So we are not creating any EMC issues. And for our installation, we have installation in the airport, in close to base station in those situations. And in the practical perspective, we didn't see any such interference, electromagnetic interference yet. And we always try to monitor that part and address part if something really happens. No problem. That's something you do not have to really worry about. It's a safety system. Yeah.
Please.
Is it the same smart meter? Do you only have one smart meter, or do you have different smart meters?
We have only one in our product portfolio. Well, we have actually two, one phase and three phase. And for three phase, there are two specifications. I mean, in terms of current transformer, 100 amps and 250 amps ones. 100 amps has smaller current transformers. 250 has a bigger current transformers. That's the differences.
My second question is regarding GDPR. So how you protect the personal information, especially when we connect the system to the internet, to your
the
platform.
Cloud, right? Yeah, and in that perspective, we play only the role of data processor, and because they are also data controller. Data controller decided where the data should be used or how should be handled, and we do not transfer those data to other controllers. So it's so you can see that it's only possible for one installer to create users' information, and we do not transfer user information in any situation. So there's no exchange of user information at all. All the information is kept in our system, or the user can choose to remove all their information from our system. We strictly follow the data protection regulations in Europe.
But may I ask where you put the host?
The cloud is in France.
In France.
Yeah, we purchased the cloud service from Orange, France Telecom. So that's a cloud service is here in France and managed by people sitting in Romania. So everything stays in the Europe. Good question.
How's your support organization built up here in Sweden?
We have support from Photomate. There's a telephone number and also email address. And also we have a technical assistance center in Europe. They have also a telephone number and an email address. So if you have any question, you can simply call or write to them.
Is there also second line support?
Yes, all the technical assistance center is already second line. They have third line help from headquarters, from other sources as well.
One more technical question.
Yeah, please.
I think it's raised by Victor yesterday.
Okay.
So regarding peak shading, so have you talked about this?
No.
Do you have this function with your products?
It's basically time of use for the energy storage. So you decided when to charge and when to use the energy. It's shifting the price or shifting the energy use from some low price point to a high price point. It's a kind of shifting of the energy. But for peak shaving, do you mean the providing extra energy to?
I think you can maybe explain it.
Kilowatt peaks.
You have situation where you need more energy during some period of time.
No, but in future, you're gonna have to pay for like when you have the peaks. So then you maybe want the battery to kick in 20 kilowatts to cut the 25 kilowatts peak.
Another way of using battery is actually to keep the output, I mean the AC side output to a certain value. That can be a way of helping you. If the solar doesn't give you necessary energy, then the battery could kick in to support the output from this side. But anything beyond the capacity of this thing is not there yet. Because this one, let's say 10 kilowatts, they have only an output of 10 kilowatt. The battery could help this one to give 10 kilowatt, I mean, most of the time. But if you want to go, let's say, 20 or 15, then you might need to add another such battery system into the system. After that, it might be possible to get more than 10 kilowatt. Is that what you are thinking, or?
But can you choose like if your house consumption going up to like some kilowatts, then the battery kicks in, and you use the battery from some amount. You understand?
I
you
think
maximize, like say that the house is actually using 8 kilowatts, but it's at 6 kilowatts, the battery kicks in and takes the rest, the 2,000 extra.
Yeah.
Oh, that kind of picture, no.
If you allow me, I will just shortly jump into the discussion.
Yeah.
Maybe help to understand the question. This is the DC coupled solution, and the peak shavings are almost always like very short time peaks. Yeah. So it always takes some time from the DC to AC side to convert it. So in the traditional way, when you have the AC coupled solution, the power can be generated very rapidly and then to compensate your peaks. In the DC coupled solution, we are always limited by output power inverter. So no matter how powerful your Luna will be, you're always limited by output power of inverter. So for example, if you will have the lowest model like 3KTL, which has only 3 kilowatts of output power, you can even connect 30 kilowatt hours system to it, but still you will have only 3 kilowatts of available power on the AC side, and this is what you can compensate only. So it will look like you'll have the peak, but inverter will compensate only to its maximum output value. So this is not for what it was designed for. Yeah.
But you have that software.
You mean?
You have the software, so you can, so it's possible to.
I mean, yes, of course. If the peaks are not oversizing the power of inverter, and it's not like you have to do it very rapidly, like in a milliseconds or single seconds, it's possible. Yes.
What is the C rate?
0.5. It's 2 hours charging discharging for one piece of size. I mean, there's a number. Let's say if you have 2 pieces. Sorry. And this is possible for a battery pack. So one piece, you have 2.5 kilowatt. And up to 2 pieces, and afterwards, 1 stack, you can have maximum 5. And with 2 stacks, you can have 10. I mean, the charging discharging power. But for that peak shaving, are you thinking some real application, or how big would be the system we're talking about?
No, but now, like, if you have over 63 ampere, you always pay for your kilowatt peaks.
But 63 is very big.
Yeah, but in future, you're going to have to pay for the kilowatt peaks also in 16 and 20 and 25 ampere. So then it's gonna be like people gonna ask for it. Automatically, nothing to peaks.
Okay, so for, let's say, for a house that has 16 amps fuse right now, but somehow with the installation of a charging station at home, the homeowner would like to have a capability of 25 amp. Such kind of situation, right?
No. I think he means that it will be some kind of penalty fee when you have a sudden increase of your maximum output.
You will pay for the maximum.
Yes. You will get some kind of penalty.
So you will take it down from the battery.
Example would be when your heating device at home starts. There will be a start-up current in a very short amount of seconds, but very high power peak. And then the question is if maybe the battery can help to provide with the power at that moment.
We can make the system, I mean, using the battery to support the output of this system. I mean, this system is staying at the same home together with your workload. So that can be a help in the sense that as long as this one has energy output, your workload in the room, in the house, will using the energy from the inverter instead of getting energy from grid.
Yeah, but it's about nighttime, when it's at night and the battery is still charged, when there is no sun power, that those peaks will happen.
Okay, during the evening time.
Yeah, it's when the sun is not up, for instance. That's when these peaks will be, and the electrical companies are charging you because you go over a certain kilowatt on the grid.
Okay, that would be interesting.
Yeah, so if it goes over like 8 kilowatts, then the battery should kick in and take it, so you don't so you're not being penalized or getting to pay a higher tariff.
I see. That's some kind of application, I mean, quite new to me. Maybe I have to check it afterwards, how to solve this situation. You mean even, is that kind of policy ready now in Sweden?
Well, no, but it's going to be.
Gonna be?
Yeah, it is for 63 and up, but it's going to come down.
I mean, how that
They
seems
need
going?
to change all of the meters in Sweden before they do this, but they're going to do it after.
But Nacka Energy, they have already that.
Yeah.
What kind of policy they have actually
Going
implemented?
from amount you pay for the circuits. Now you pay for how many kilowatts you're doing at the peak hours.
Even within the circuit fields,
Yeah.
you have to pay for the.
Yeah.
Wow. Okay, because at the beginning we think only about the circuit. Right now, there's another level below the circuit breakers.
Yeah, they're trying to make it non-understandable.
Okay, there's another level consideration even now. And how the peak was, I mean, how the level was defined. Let's say for one home.
They had not said that. Maybe
It's different. It could be like 25 crowns per kilowatt or 50 crowns or yeah. So and then it's the highest peak in the amount you pay for.
Okay, let's say for one home, 1 meter, if your input goes about 5 kilowatt, then they add 20 cents to each kilowatt hour.
Yeah.
Something like that.
Yeah.
Okay, then you would like to use battery to keep the shape it down. It should be possible, but it might need some control from the batteries to do that. And also this one needs to be considered together with the working mode of the battery, when to charge, when to discharge, right?
I mean, the energy meter will know when you hit that level.
Yeah,
so,
definitely.
I mean, an API to do the programming from the energy meter. And if there's no juice in the battery, then tough luck.
But if there are electricity in the battery, then you can keep the system a little bit lower. Yes, that's a good application, but I do not know this application until now. Is that local to Stockholm or it will be everywhere in Sweden, this kind of policy?
All Sweden.
All Sweden.
Exactly. And they were supposed to calculate the profits for our customers without having a clue what it will cost.
Well, yeah. Fuse itself doesn't tell anything, doesn't tell enough things. No, I see. Even for home, peak shaving became something. Because we have big batteries, and one application of those big batteries actually to do the peak shaving. But in that case, it's mostly for the application that they can't get enough power from the grid. Let's say a big charging station, they need 2 megawatts from the grid, but they get only maybe less than 1 megawatt. The big battery over there could help to provide necessary power during some time. But in this case, the peak shaving more or less means battery in the home. You need to kick in when the application goes above certain level.
Actually keeping it down the whole time.
Yeah, keep it down all the time as long as possible.
So you don't go like this.
It would be nice if we can have a better understanding about this policy. Is that up to the energy company or up to some regulations from
The grid companies.
from grid
Yes.
company. So the grid company has the possibility of implement this policy. Okay. But some detailed information would help us to create more efficient solution for this situation.
Vattenfall say they was going to implement it 2020, so
But it's not there yet.
no.
How is the interface? What's the possibility? Let me tell you, I've never sold a Huawei product before, so I'm here to be convinced. How is the interface regarding how to manage the battery? Can you, with an easy interface, say that between this time and this time it should charge, for instance, from the grid?
Yeah, it is. We have a so-called time of use mode of using battery, and let me see if I can find that on the internet. And time of use means that you can define which time slot you want the battery gets charged, and at which time slot you using the energy from that battery.
Yeah, it would be interesting to see if you can also tell it to discharge to the grid.
Right now, it's not there yet. I mean, maybe I know, but there are still quite some third-party applications in the development, trying to make some smarter use of our batteries, such as discharging to the grid, such as to do the frequency support. Those things is happening on the way, and that can bring also benefit to the home users.
Yeah, there's a lot of money to make there.
Yeah, you're right. A lot more money over there.
But you can charge from the grid to the battery, right?
Yeah, yes, you're right. That thing can do both DC and AC and AC/DC. I mean the inverter.
Yeah. But for now, you cannot discharge from the battery to the grid.
Right now, no. I mean, we do not have this application to enable that, but we have the necessary interface, programming interface to do that. Let the battery to discharge to the grid.
Because I think you're not allowed to do that in most countries, right?
Yeah, it depends on the policy. Yeah. If you can, some country you do not even allow to export those solar energy to the grid.
Okay.
And we have a function to control the energy output to the grid on the point of connection. Well, this is a view. A FusionSolar. If you choose to access this FusionSolar, one way is using web browser, and in battery it should be here in the, where is it? Under the plant. If you do the device management, you can choose the battery and give the battery a different way of using it. This is the account of a installer. Say operation mode. You can change it to time of use, and see there are 3 modes. This one means anything generated from the solar modules should be, I mean, beyond the necessary, should be beyond the usage, should be put into the battery, and the battery just discharge it whenever you need the usage. And this one is try to use the battery to to keep the output power of that inverter to a certain level. And this one is the time of use. Say for this time, you get a different time. Say for 2 hours, 3 hours, you can do charge, and which day you want to do that. And you can add another time slot from, that's a time slot. And the idea is quite simple. You give a different time slot and give different action to each time slot. That's so-called time of use.
But that was for the installer and not for the user.
Right now it's a installer action, but later we will change it to give this possibility out to the user. And we see this modification is quite. I mean, during the summertime, it's maximize the self-use. It's make more sense, but during winter time, maybe this time of use makes more sense. So such changing happens every year, twice a year. It would be nice if, of course, we see that's the issue, and we are solving that issue. Yeah, any question? Would be really welcome. That kind of peak shaving is a really good information.
How quickly is that updated?
Sorry?
If I go in and say in 5 minutes I want to start discharging, can I do that? And is it updating that fast or?
You mean from giving command to the energy show out?
Yeah.
Yeah, it's in the range of second, so relatively quick, and that's why we can support certain service, frequency service in Sweden, and those kind of service require your response within, let's say, 5 seconds when they give command until you have the energy drag in or output to the grid. It's rather quick, right? You can continue with this. That's time slot definition. Say discharge. And you can give how the thing is going to be repeated.
Forced charge, discharge, what is that? Is that?
That's another way of using this battery. Actually, you can force to charge the battery, even if this battery is not in those time of use or whatever mode. And here you can set a definition that you just want to keep the level of the battery to a certain level for some reason. Before, let's say, before something you predict there is a outage, or somebody the energy company told you that there is something going to happen, and you want to charge it instead of immediately, then you do this charge immediately.
Can I allocate a certain percentage of the battery for backup?
Yes, when you are backup mode, you always have a percentage setting here. Usually you do not go below, let's say, 15 or 20%. You can always keep something over there. For charging, you can also setting if I charge to 100% or 90%. That's called 100% dips of discharging.
Can you choose charge from AC?
Yes, charging from AC can be enabled.
Okay.
And also for this side, you have the possibility of setting such figures that how much the capacity and how much the power you're going to use when charging from AC. There are quite many options to leverage. But that peak shaving is really something that we need to consider about. Okay. The battery is very interesting part of this solution.
It's coming more and more.
It's coming more and more. Okay.
How many cycles is the battery?
From the warranty perspective, it's not calculated as in terms of cycles. It's calculated in terms of energy output. So for the battery, one piece of battery pack, the warranty time is 10 years. So within 10 years, they can discharge at least 16 point something megawatt hours energy. So if you run into issue before that many of energy output was arrived, then the warranty condition is triggered. You can ask for replacement. In addition to battery, the inverter itself is not so interesting, right? They're just working.
It's a dumb box.
Yeah. Dumb box, yeah, I see. They are the center, but they are the dumb box. Oh. Yeah. With when they are sun, they export energy. When the sun, during the evening time, they just sitting over there doing nothing. Yeah. Okay. Battery give more consideration. I see. Then let's ship more batteries to the customer's home.
That easy, right? Yeah.
I mean, you can expand it one by one piece at a time. That's something really you can think about. You don't have to.
Where's the manufacturing? China? Of the batteries?
Yeah. Right now it's in China. We are trying to diversify the manufacturing, but still, lithium battery is really hot nowadays. And many factories reserve only the capacity, production capacity for the car usage.
Is it the same modules?
Sorry?
Is it the same kind of modules for cars too? Or?
No, it's not. It's LFP cells for car. They use the right now. Some car also choose to use LFP battery cells, but mostly it's not LFP cells.
Do you have any idea how it will be for the car batteries to be used? For the home as well, as a backup, or as to use them?
The thing is that we are, in terms of development, we are thinking about trying to understand the market requirement. We will develop some vehicle to grid solutions. So when your car get home connected to the home electricity system, then we might also use in the future. I say in the roadmap, also using the battery, the big battery in the car. to support the home use or to make a more clever use on top of that.
Question there is, how is the thought there? Will the car somehow be connected to of course, the charger, and the charger connected to the inverter?
To this one, yeah.
To the, yeah.
Not directly connected, but still managed by it. Maybe some communication connections.
Yeah. Interesting.
Yeah. Yeah, we witness that charging is getting more and more popular. I mean, car charging in especially in Europe, and it's based on the charging and the charging. There are quite some things can be done and has to be done, and the batteries in the vehicle can need also to be considered. It's quite common that a vehicle, a car, ordinary car, can have, let's say, at least a 40 kilowatt hours battery built in. Some premium might have even 80 or 100 kilowatt hours battery. So that's a big battery, and can be a good support, especially for this peak shaving during evening. It can be a very big support to this kind of applications.
One question regarding the Luna battery.
Yeah.
So when you ship out, so will they stay in the same percent charged volume, or I mean it's different percent? For example, this piece it's 20%, next piece it's 40%. Because I'm wondering if we set up in different time, will it create any damage?
The requirement is that when it's shipped on site, it has to be connected to the power. I remember it's within 1 month or 2 months, within certain limit of time. So at the beginning, it's around 50% charge.
Okay. For all the batteries you shipped out?
Yeah, should be in that level.
For example, okay, let's say one customer installed 1 battery this year.
Okay.
So next year he will put 2 more. So
okay.
Do we need to configure?
No. Just
No.
put in, the optimizer will do the charging, discharging, and balancing the
Automatically.
Okay. You do not need to pre-charge it.
Okay.
Or simply do not do it.
The optimizer in the control unit.
Sorry?
That's the optimizer in the control unit?
Optimizer in each battery stack.
Oh, okay, cool.
It's always just put in or take out the old one. You don't have to do any pre-charging or measure the SOC. Leave it to the system.
Is it that if the battery goes under a certain percentage of the life expectancy, will it then just shut off, or will it still work if it's 40% effective?
Well, the warranty condition is that 60% is a minimum of state of health or capacity, that we have certain guarantee of the performance or behavior. So it's really suggested to do the replacement on 60%.
But it will still work if it's on 50% health.
It might work, but we can't guarantee that.
What is the round trip efficiency of the battery?
You mean charging it and then discharging it? It's around maybe 80 something, 80, close to 90%. So 1 kilowatt hour you put in, then you get out maybe 0.88, 0.87 kilowatt hour. And that round trip is a way of showing the benefit of this power electronic, like optimizers in the systems. Because at the beginning, if you just have battery cells directly connected to each other, you can have better, let's say, round trip efficiency. But as time moving on, without power electronics, the battery's round trip efficiency drops really quickly. But with the optimizer, you can maintain a relatively slow dropping curve on the round trip efficiencies. So over the lifespan, you can witness more energy output from the battery cell. I mean, with optimizer compared to the situation without optimizers.
And one question about the batteries is that the temperature on the, if you install the battery on outside of the house,
okay,
does the temperature affect the outputs?
yeah, affect the output because there are heaters inside. The battery will heat itself too close to, I mean, above 0 degree, then start working. Before that, it will simply heating itself. So the temperature, so it's preferably put it indoor for the better performance. But of course, the specification is 20 minus. You can put it outside, 20 degree minus. You can put it outside. And most of the year, you know, Sweden do not have that low temperature. But if the temperature drops below 0 degree, the heater will kick in. Yeah, battery is a big investment, or it's more interesting.
In the manual, I think about the lunar battery, I think it says minus 10 degrees.
Sorry?
In the manual.
Manual, it's 20. We updated it. Yeah.
But it says minus 10, I think.
It's updated. Old specification is 10. We have it updated already. 20 minus. Anything?
If there's no more questions, maybe we can start the lunch.
Yeah, call and.
Yeah, we can have 1 hour lunch. 1:30 we can continue.
Yes, we are here, and welcome to write to me or call me if you have need any support from solution perspective. Please let me know.
And we can have lunch here. We have some kind of fast food sandwiches.